Our problem layout is Vidit, him, walks into Steast and is debating what he will choose to eat for dinner. Vidit will definitely get an entree unless there is a good dessert option. On any given day, there's a 25% chance that Steast has a good dessert. If there is a good dessert, Vidit will not get an entree. For entrees, Vidit has a 40% chance of getting Italian food, a 20% chance of getting Polish food, and equal chances of getting American or Asian food. He will only choose one entree. Italian food is always non-vegan, Spanish food is vegan 25% of the time, Polish food is vegan 15% of the time, American food is vegan half the time, and the Asian food is vegan 75% of the time. The first part, what is the probability that Vidit has a vegan meal given that there are no good dessert options? I went ahead and wrote out all the probabilities listed in the problem layout. So then to solve, we have to find all the ways that Vidit can get a vegan entree. So in order to do that, you just have to find the probability of it being an Italian entree plus the probability of it being vegan given that's Italian entree, and then you get your answer. And then we're gonna add it up to each case. So we have also, in addition to the Italian and vegan, we have Spanish and vegan, American and vegan, Polish and vegan, Asian and vegan. So that means we had to find the probability of Spanish and then the probability of vegan given Spanish, which we have all listed out here. It's 5 separate probabilities that you can add to get 0.205 as our final answer.
The second part of our problem is asking what's the probability that Vidit has a vegan and American entree given that there are no good dessert options. We're just going to start by rewriting the question. So we know that Vidit's getting an entree since there are no good dessert options. And by using the same methodology that we used in the first problem, this turns into probability that it's American times the probability that it's vegan given American, which we already have listed out in our given probabilities. So when we plug in our givens, we get 0.1 times 0.5, which is going to come out to 0.05 as the final answer. The third part of our problem says, suppose Vidit grabs a dinner plate. You see that the entree Vidit took is non-vegan. What is the probability the dish is Asian, given what you saw? So again, we're first going to start by rewriting this question. For this question, we're going to have to use Bayes' rule because we don't know how to solve this yet. So when we rewrite it with Bayes' rule, we get this. The probability that the dish is Asian times the probability that the dish is non-vegan given that it's Asian, all over the probability that it's non-vegan. From this formula, we already have 2 values that we basically have the answer to, and this is the only one that we're going to have to do real work to solve out. So first, let's do the easy ones. For the probability that the dish is Asian, we know it's going to be the same as the probability that the dish is Asian given that Vidit grabs an entree, which is one of our givens, and it's equal to 0.1. Next, we have the probability that it's non-vegan. We already calculated the probability that it's vegan in the first part of our question. And so because there's only 2 possibilities for an entree, either vegan or non-vegan, we can just take 1 minus probability that it was vegan to get 0.795. And now we have to find the probability that it's non-vegan given Asian. To solve for the missing conditional, we're going to break this into 2 easier parts. So let's think about the possibilities of getting an Asian entree. You can either get an entree that's vegan and Asian, or non-vegan and Asian. And so rewriting that out as a probability statement, you get probability that's Asian equals probability vegan and Asian plus probability that's non-vegan and Asian. By using the same methodology that we did in the first 2 parts, we can rewrite this as, so from here we have a long equation that we already have almost all the values to except for this, which is the same thing that we're trying to solve up here. Now let's plug in all the values and solve for x. So after plugging in all the given values that we got from the beginning, we get an answer of x equals 0.25. So now for our third part, we have an answer of 0.25. Now we have all the values that we need to plug it into the formula and get our final answer. 0.1 times 0.795 all over 0.25 is going to equal 0.0314. Okay, so for the first part of the problem, we figured out that there were 5 ways that it could be vegan. We added all of them up and then got 0.205 as our final answer.
In part 2, we basically used the same methodology that we used here, where I and B is equal to probability of I times probability of B given I, to find the probability that it was vegan and American. And then in the third part, we used Bayes' rule and solved for the missing conditional.
To get a final answer of 0.0314. 1-4.